You are welcome to JoeNewton online class. In our class today, we are learning physics, and the topic particularly is resultant force. And of course, we know that force is a vector quantity. Then, what do we mean by a resultant force? A resultant force simply means that single force that will have the same effect in magnitude and direction as two or more forces acting together at a point. That is the resultant force. Okay, now let's look at the diagram on the board. We are given four forces acting at a point in different cardinal directions. We have north, have south, we have east, and we have what? West. So this is north direction, this is north, this is, of course, this is east, this is west, and this is south. Then we are asked to calculate the magnitude of the resultant force. Of course, the question did not emphasize the duration, so we are just finding the magnitude of the resultant. Good. Now, in solving this, the first thing we are going to do is to resolve this vertically and horizontally. So to know the effective force in the vertical direction and in the horizontal direction, if you look at this is opposite. So this is the vertical direction, and the forces, there are two forces acting in opposite direction there. So we have to resolve it to know the effective. And when two forces are in opposite direction, vectorially, by vector resolution, you do what? You subtract. But if they are going in the same direction, then you can add. Okay? So in this case, the effective force, because this one is like opposing this one. That's what it means. Good. Now, we have first for the north, we have that 20 Newton. Now for vertical, let's put it this way. Vertical, for vertical, we have 20 Newton minus 8 Newton. We are left with 12 Newton. And this 12 Newton, which direction do you think it will go? 20 minus 8 is 12 Newton. So the effective force will go in the north direction. Go in the north direction. So we have this should be 20 Newton north. Then for the horizontal component, we have 15 Newton minus 10 Newton. Then that will give us simply 5 Newton. And which direction do you think it will go? Will it be east or west? Of course, the effective force will be in the west direction because this one is higher. So we have in the west. So we can now we can now represent the force now using triangle. Okay? So in this we have the three sides of a triangle of simply the north and horizontal effective force, the vertical component and horizontal component of it, which eventually will lead you to a right angle triangle when you complete the three sides of the triangle. So this we have this. This is what you're going to have. We'll have this. We have this. With here now, here is the north, here is the west. So here we have 12 Newton, and here we have 5 Newton. So that is it. So with this, you can see the pointing direction. So you should be mindful of this. It's very important in vector. Direction is very important in vector, not just anyhow. Okay, the resultant now is this line. So this line is the resultant. So here is our resultant force. We can call it F resultant, the resultant force. So for us to find the resultant force, let me label it F resultant. Here is F resultant. Then put it F resultant. Good. So this is like F in the vertical direction, Fy. This is like force in the horizontal direction, It's like our force in horizontal direction, Fx. In the horizontal direction, this is in the vertical what? Direction. Then this is the resultant. So to find the resultant, we now have that. We now have this way using Pythagoras theorem. You can use Pythagoras theorem easily here to find the resultant of this force, since we have the two other forces in the other two sides of the vertical and horizontal, which could complete a right angle triangle. And then Pythagoras rule mathematically says that the square of the hypotenuse is equal to the sum of the squares of the other two sides of a triangle. That is the idea, the knowledge you are borrowing to solve this. Okay, because if you complete this, look at this. If I make this, I have right angle triangle. That is right angle at this place, and this place is equal to this place. For you to see where the idea comes from. So we have that F resultant squared is equal to Fx squared plus Fy squared. So that is it. Okay. So with this in mind, we can simply say that F resultant squared is equal to, what is our Fx? 5. 5 squared plus 12 squared. That is for this. So we will now get that this will give us what? 25 plus 144. Good. And that will lead us to 25 plus 144 will give us 169. If you add it, you get 169. So to get our F resultant now, it will be take the, because this is F r square, that's F resultant square. So you take the opposite of square, and the opposite of square is square root. That is square. You take the square root of both sides. To remove this square here, you take the square root of both sides. That is square root of this. When you take square root of this, you get F resultant, which we are looking for, because we are not looking for F resultant square. So you have to evaluate until you get F resultant itself. So when you remove this, you take square root of this. So equal to square root of 169, which is equal to 13, because you know that 13 times 13 will give you 169. So when we say square root of a number, we mean which number will multiply itself again to give you that same number. If you can do a fact check here, if you fact check here, you see that 13 times 13. So you know that we don't just book the number. 3 times 3 is 9. 3 times 1 is 3. 1 times 3 is 3. 1 times 3 is 3. 1 times 1 is 1. So you can see how we got that. This is 9, 6, 1. So this is how we got this 169 here. And the 13 times 13 will give you what? This is how we got this 13 here, because this 13 times itself again will give you 169. So the resultant for the magnitude of the resultant force in this vector representation of forces acting at that point is what? 13 Newton. What does it imply? That this 13 Newton could have the same effect in magnitude and duration as these forces acting together. It's not algebraic summation. Do not make that mistake. In vector, we don't do algebraic addition, just adding all of them. No, we resolve it. We call it resolution of vectors analysis. Thank you for paying attention to this class. I believe with this, you can solve similar questions at ease. Then to enjoy more of this, keep following me on this Facebook page and be kind to share this video to others so that they will also enjoy this learning with us. For more of this or private tutorial on physics and mathematics, do not hesitate to drop message for me in the inbox or chat me with my WhatsApp number here. You can also visit my YouTube channel at JoeNewton Online Physics and Maths, and also subscribe for free to keep learning physics and mathematics with fun. Bye.